Okay. Next item on the agenda is going to be our conversation about dates, times, calendars, and all of the parts related to this stuff. You know that we already had a number of encounters with situations where we wanted to talk about days and times. Specifically, we had the airline scheduling system, which was trying to refer to military time just as an integer in the range of 24-hour period. Also, our current homework, which is asking to input 3 integers and convert those integers to a text version of a date, are getting kind of close to this topic. But finally, we do get to start this conversation very specifically. When we talk about dates, day and time structures or classes in Java, in general, we can keep in mind those three system API classes. Gregorian Calendar allows you to obviously perform calendar operations, right? So we can manipulate months, we can manipulate days, we can add or subtract days, and all of this computation is done correctly according to the type of calendar that we're using, right? Because human calendars are different. Gregorian calendar, or other name for it is Christian calendar. You can research its history and also compare it to other types of calendars that exist. But this is a class that encapsulates and gathers the whole range of methods or operations specific to the calendar, and although it goes and manages days and days of the week and years and leap years, so everything related to the calendar type of work. In addition to that, it still records the time of day, and even to the detail level of seconds and milliseconds. So it does capture more than just a date information, but also the time. Then we also have a date, which is much simpler. It's a much simpler version of a timekeeping object. What it does differently is that it has it's sort of like a minimalistic version of a time tracking object, which can be initialized to current date and time. But although it says date, in its internal storage, what it stores is just only one long integer, which keeps track of milliseconds since the beginning of Unix epoch, which is January 1st, 1970. Right? So this is internally much simpler object. What date objects are very effective with is that the dates are great for those ones. The dates are when you really don't need specifically to work with the calendar parts. You can use date to keep track of time, not necessarily date, but also keep track of time, compute differences in time, and compute differences in dates and times, and essentially allow sorting by date and time. So as you can see, there are different aspects to this. There's also time aspect to everything. So Gregorian calendar, some of the operations are available in Gregorian calendar. Some of operations kind of overlap And some operations are much more straightforward just with a date class. So we will see by simply looking at methods available in date and methods available in Gregorian calendar. And there is a helper class that allows us to quickly convert internal storage of date and time into a printable version, and this is the DateFormat class. So let's go quickly and explore these classes and maybe run some simple, tests. So like I told you, although named Gregorian calendar, right, it stores the date and time information to the accuracy of milliseconds. Okay, so this comes from the utility package, so we have to import it from that package. So common constructors are, the common constructors are like those, and you can always look up Oracle documentation, official documentation for different types of constructors, but generally speaking, you do, for instance, when you use like empty parentheses, it just gets initialized with your current local time, date and time, right? So if you want to capture the current date and time, you just create a Gregorian calendar instance and use its default constructor to capture that information. So we'll try to do some experiments with this later on. And others are obvious. I think other constructors are obvious, allows us to construct for the specific date and time. All right, so to get the current date and time, just construct construct Gregorian calendar with empty parentheses. Soon we're going to see how you extract information from that object. Okay, so these are the examples, and I think it's just obviously kind of trivial to understand. All right, now notice that there is a military notation used with the constructor, right? So this is 2012. Apparently, we use day, day, a month. I'm sorry, year, day, and month. I'm sorry, year, month, and day, and then we use time, and this is hours and seconds. I'm sorry, hours and minutes, and the hours and minutes are also specified in military time, right? So we go around the 24-hour clock. So more about this as we go to specific examples of this. And it's one of those classes that you can experiment with endlessly. Like you can find some really interesting ways to use a calendar object and just see what it does for you. Sometimes people have to analyze the sequences of holidays, the different calculations related to weekdays and weekends, things like that. So there's just like plenty of different things that you can experiment with respect to the functionality which is available from the Gregorian calendar. Okay, so it comes with the whole bag of constant static data or constant variables, which are just like integers, but they are included. So instead of using methods specific to different parts here, like for instance, hour or minute, and other components, instead the same set and get methods will be used. Instead, there is an extra parameter that takes a specific constant. Okay, and so these are the constants. You can see that there are constants for days of the week. There are obviously constants for all months, and sometimes you're asking for the month, then you're going to say, give me the month, and you will be using these constants. So it's slightly different type of interface in terms of not method names, but rather, instead of creating, say, 7 extra methods for the day of the week, there is a constant, but the name of the method is the same. So it's true with the months, right? So that just makes sense to work with this type of interface. So you can see that there are set methods, and there are add methods, and there are roll methods, and there are get methods. This is an interoperation between the date class and the Gregorian calendar. So for instance, if you want to go from a date, so let's try demonstrating this. So supposedly I construct a date. So let me just erase this prior sample, right? And we start again, and we say, all right, let me have a date today. Today equals new date. All right. So this, what is this? Oh, yes, of course, I need to fix my imports because it comes from the utility class. All right, fine. So, but using default constructor with a date, just like with the Gregorian calendar class, will give you the current date and time. Remember, although it's called date, it's really date and time with an accuracy of milliseconds. So then if I wanted to go from here to Gregorian calendar, say day, right, equals new, right? So create it this way. We know that it does work with the current date and time, the default constructor. So we'll just once again fix the imports. Both come from the utility package. It's just those, of course, need to be imported. That's fine. But if I wanted to use my date and set it inside my Gregorian calendar day, I would say day set time, right? There's the set time, and it will take my date instance, such as today. There is no constructor that does that, but there is a method that does that. So you have to go by the method, because if I wanted to try it, right? If I wanted to try it, unless it has changed lately, no. It basically says no, there is no suitable constructor, which I find kind of surprising a little bit, but anyway, it's the thing is that essentially the information of the date and the Gregorian calendar do overlap in a great deal. So that's why they decided to not to include the specific constructor. But nevertheless, there is a set time, and its name is a little bit confusing because instead of saying set date, it says set time, but takes the instance of a date class as a method parameter, right? So it is what it is. When you work with dates and times and calendar parts, you just sort of, navigate your way through a maze of methods. There are lots of them. But I just wanted to show you that, yes, you can go from date to Gregorian calendar, but you have to use the specific method. Okay, moving on. There's also this variety of set, add, and roll. So set is perhaps pretty straightforward. You want to set a specific, say, year or other year, month, day, and other pieces. That's fine. But you may also add and subtract. Say you have a current date, but you want to add like maybe 35 days to it. So clearly, from the calendar perspective, this is a significant change because you may end up with the month changed and even year changed, not just only the day. So with that respect, you use the add, and add, of course, will take both positive and negative numbers, so there's no subtract. You just use add and specify a negative value, and you specify that constant, which say, let me add X amount of dates, or let me add X amount of months, and it will do the math properly for you.